Hey good people, welcome back. In this video we're going to learn how to factor two special types of quadratics. One is called a perfect square trinomial and the other is called a difference of two squares. And the perfect square trinomial becomes really important for factoring any type of quadratic. It's sort of the technique upon which the quadratic formula is built, and that's something we're going to be getting into in a few weeks. It's a really powerful technique that enables you to factor quadratics even when they come out as decimals. But we're getting a little bit ahead of ourselves, so let's just do a few basic examples in this video. I'm going to upload this guided note-taking worksheet as a blank copy. I'm also going to upload a PDF of the annotations that I make in this video. And there's going to be an assignment, a Math Excel assignment that's related to Chapter 8.7. This is going to be due on Friday by midnight, and the problems are 13 questions exactly like what's presented in this video. So let's go ahead and get started. A perfect square trinomial is a trinomial whose factored form is the square of a binomial. And you can recognize a perfect square trinomial because they always have this property here. The middle term is always equal to twice the square root of the first term multiplied by the square root of the last term. That's what that a squared plus 2ab plus b squared means. And if that occurs, you're always allowed to factor this as the quantity a plus b squared, where a is the square root of the first term and b is the square root of the third term. Now, if the other case happens where the middle term has a negative, and it's equal to negative 2 times the square root of the first term times the square root of the second term, or the third term, you could factor that as a minus b squared. So we look at trinomials and we try to figure out if they're that special case first, because if they are, it's really easy to factor them. So let's go ahead and take a look at an example off to the right. X squared plus 6x plus 9. Is this a perfect square trinomial? Well, we have to look at that middle term. Is 6x twice the product of the square root of the first term and the last term? What's the square root of x squared? X. What's the square root of 9? 3. And is 2 times x times 3 equal to the middle term, 6x? It is, in fact, and therefore, this is what we call a perfect square trinomial. And if that's the case, it can be really easily factored. All you do is you change it into a binomial squared, and the first part of the binomial is the square root of the first term. What's the square root of x squared? X. And the second part of the binomial is the square root of the third term. What's the square root of 9? 3. And you're always going to use whatever sign's in the middle here. There's a plus in the middle, so we use a plus there, and that's our answer. And just to verify that this does in fact equal to the quantity x plus 3 squared, we can expand that out and FOIL it just to prove that this does work. First times the first is x squared. Outside times the outside is 3x. Inside times the inside is 3x. Last times the last is 9. We're going to take that middle two terms, 3x plus 3x, and combine them. And we can see that this does in fact equal what we started with. So this is the correct factored form, the quantity x plus 3 squared. All right, let's go ahead and do another example. Factor the expression x squared minus 4x plus 4. Well, we're going to ask ourselves, is this that special case? Is negative 4x 2 multiplied by the square root of this times the square root of this? Let's see. What's the square root of x squared? X. What's the square root of 4? 2. And negative 2 multiplied by that is equal to negative 4x. And that means we have this perfect square trinomial type where there's a minus in the middle. So we can very easily factor this because it's a perfect square trinomial. We just set up our little framework there, a binomial squared. To get what goes here, we're going to take the square root of this. What's the square root of x squared? X. And to figure out what goes here, we just take the square root of this. What's the square root of 4? 2. And we always use whatever sign's in the middle. We're going to put that in the middle here. So we have a minus sign in the middle, and that's our answer. And it's really that easy. You can check your work if you like by foiling it, but take my word for it, it is the correct answer. Go ahead and do this try problem. You can pause the video now if you'd like, but I'm going to go ahead and answer it. So first step, try to identify if you have a special type of a quadratic. We do have a perfect square trinomial, and the reason is because this middle term here is -2 multiplied by the square root of this multiplied by the square root of this. -2 times the square root of x squared, which is x, times the square root of 9, which is 3, is equal to -6x, and that's what we have in the middle. So this checks out. It's a perfect square trinomial, and if it is, it can very easily be factored as a binomial squared. The square root of x squared is x. The square root of 9 is 3. We put this sign in the middle. It's a negative sign, so I'm going to put a negative sign there, and that's my answer. Let's do another example. Factor by using the perfect square trinomial formula. This one has a leading coefficient. We're going to still handle it the same way. We have to verify. We ask ourselves, does this middle term equal -2 times the square root of the first term times the square root of the third term? Is that equal to -56x? What's the square root of 16x squared? In other words, what could you multiply by itself so that the answer is 16x squared? Well, that's the square root of 16 is 4, and the square root of x squared is x. So that's 4x. And over here, what is the square root of 49? The answer is 7. If we multiply all this together, -2 times 4x is -8x, multiplied by 7 is -56x. So it does check out. This is equal to the middle term. So this is a perfect square trinomial, and if it is, you can just go ahead and write your framework of your answer. It's a binomial squared. To get the first part of that binomial, we just take the square root of this. We already did that over here. The square root of 16x squared is 4x. To get this part over here, we take the square root of this. Square root of 49 is 7. And we're always going to use the middle sign here. Whatever sign belongs to the middle term, we put in the middle of those. So that's a -56x. I put a minus there. And that's our answer. We factored this by using the perfect square trinomial formula. That was much easier than what we usually do, the factoring by grouping method. Really, it just involved taking the square root of 16x squared, putting that answer there, take the square root of 49, put that answer there, put this sign in the middle, and then we're done. Why don't you go ahead and try problem number 2. You can pause the video, try it, and then resume the video and check your work. First step, we want to verify, is this a perfect square trinomial? Is that middle term equal to twice the product of the square root of this times the square root of this? Well, let's see. We're seeing if that 60x is equal to 2 times the product of the square root of the first term and the last term. So what is the square root of 25x squared? The square root of 25x squared is equal to 5x. I'll put that there. And what is the square root of 36? That is equal to 6. 2 times 5x is 10x, times 6 is 60x. So this checks out. This is a perfect square trinomial. Because it's a perfect square trinomial, we can use the perfect square trinomial formula, which says that you can factor it as a binomial squared. You take the square root of the first term and put that in the beginning. Square root of 25x squared is 5x. The square root of the third term, put that as the second part of the binomial. The square root of 36 is 6. And take whatever sign is in the belonging to the middle term there and put it in the middle of those two terms. All right, so 60x is positive, so I put a plus there. Done. So 25x squared plus 60x plus 36 is equal to the quantity 5x plus 6 squared. Alrighty. So your Math Excel coming up, it's due on Friday night. It looks exactly like these type of problems we're doing in this video. Just continue watching the video, maybe even have it open in a separate tab, and you can kind of match up the problems. And that's a really good way to learn this, just by practicing problems on your own. All right. Find the area of the square below is equal to 16x squared plus 16x plus 4. Find the side length of the square. This is a problem that you're going to see in your Math Excel. If it was like back in, elementary school, you'd have a much easier scenario where they give you a square, they tell you the area. Let's say the area was 9. And what would be the edge length such that the area of this square would be 9 square units? Well, it would be 3, because 3 times 3, the length times the width, would be equal to 9. So we got that just by taking the square root of the area. And that's what we're going to do here. But we're going to have to kind of think, if we're taking the square root of this, that's not so easy. It's better if we have it in that factored form first. And this just so happens to be a perfect square trinomial because the middle term is equal to 2 times the square root of the first term, 16x squared, times the square root of the last term, 4. 16x squared has a square root of 4x. 4 has a square root of 2. 2 times 4x times 2 is 16x. Is that what we have in the middle here? Yes. So this is a perfect square trinomial. So we verified that it's a perfect square trinomial. That means it could very easily be factored as a binomial squared. To get this binomial, we simply take the square root of the first term. The square root of 16x squared is 4x. The square root of the last term, the square root of 4, is 2. And we use the sign that we have in the middle there as a plus sign. So the area is equal to the binomial 4x plus 2 squared. If you remember how to find the area of a square, you simply take the length times the width. So what that means is that the length is 4x plus 2. And the width is also 4x plus 2. And that's why the area is 4x plus 2 squared. So what is the edge length of the square? It's 4x plus 2. That's our answer. So we basically took our trinomial, we factored it as a difference of, or as a perfect square trinomial, and we just got rid of the square because they were only asking for the edge length, not the entire area. Alrighty. So the final answer to that question was 4x plus 2. Let's go ahead and look at a try problem here. You can go ahead and try this on your own if you'd like. Pause the video. I'm going to go ahead and answer the question. I want to begin by verifying that we are in fact working with a perfect square trinomial. To test that, you take that middle term, 84x, and verify that it is in fact equal to 2 times the square root of the first term, which in this case is 49x squared, multiplied by the square root of the last term, which is 36. The square root of 49x squared is 7x. The square root of 36 is 6. 2 times 7x is 14x, multiplied by 6 is 14 times 6 equal to 84, let's say. It is. So this is 84x, and that's what we have on that other side. So it checks out. This is a perfect square trinomial. A perfect square trinomial can always be factored as a binomial squared. And to get that binomial, you simply take the square root of the first term, the square root of 49x squared, which is 7x, the square root of the last term, which is 36 square root is 6, and you use the sign of the middle term, and that's it. So they're only asking for one of the side lengths. This is the entire area. To find the side length of a square, if you know its area, you just take the square root. Well, the square root of anything squared just gets rid of that squared. So the answer is 7x plus 6 as edge length of 7x plus 6. So when you type this in your Math Excel, you're not going to want to include this squared here. You're just going to type it in like that because they only want one of the edge lengths. All right, one more example. Factor this perfect square trinomial. 9x squared minus 6x plus 1. We have to verify that this is in fact a perfect square trinomial. Is the middle term, negative 6x, equal to negative 2 multiplied by the square root of the first term, 9x squared, multiplied by the square root of the last term, 1. If this is in fact equal to that, then it is a perfect square trinomial. What is the square root of 9x squared? It is 3x. What is the square root of 1? It is 1. Negative 2 times 3x is negative 6x times 1 is also still negative 6x. So yeah, this checks out. This is a perfect square trinomial. And that means it can very easily be factored as the first term. You take the square root of it. What's the square root of 9x squared? It is 3x. What's the square root of that 1? It is 1. And you use the sign that's in the middle there. And there's a negative in the middle. You're going to put a negative in between those. That's our answer. All right, you could do this try problem right here. 100x squared plus 40x plus 4. Pause the video, try it on your own for some practice. The first thing you really want to do is to never assume that it's a perfect square trinomial. You have to, in fact, verify first that it follows that format. What we're testing is that middle term, 40x, is it equal to 2 times the square root of the first term multiplied by the square root of the last term. The square root of 100x squared is 10x. The square root of 4 is 2. And 2 times 10x is 20x. Multiplied by 2 again is 40x. So it does check out. It is a perfect square trinomial. Since it's a perfect square trinomial, it could very easily be factored as a binomial squared. And we just take the square root of 100x squared as our first part of this binomial, the square root of 4 as the second part, and there's a middle term 40x positive, so we're going to put a plus sign in the middle of those two, and that's our answer. All right, and the other type of problem we're going to see in this Math Excel is the difference of two squares. That is probably even easier. The difference of two squares is a special type of quadratic that kind of arises because you had identical binomials except one was positive and one was negative. And when that happens, they kind of cancel each other out and you're left with, instead of a 3-term quadratic, you only have a 2-term quadratic. And we haven't really seen any of these yet. But here's a nice example over here. If you were to FOIL this, x times x, negative 2 times x, 2 times x, and 2 times negative 2, you get negative 4. Notice that this negative 2x and this 2x, they're the same magnitude, but they're opposite in sign. So they cancel one another out. Negative 2 plus 2 is 0. So we have x squared minus 4. And that's why this original thing didn't have that middle x term. It sort of got canceled out. You can see these cancel one another out. And if you can recognize when that occurs, you can factor these as a product of two binomials. Over here, see how there's no middle x term? That's because it was canceled out. And the rule is to change this into two binomials, you simply take the square root of the first term, the square root of x squared is x, and you put that here and here. And the square root of negative 49, or of 49 rather, is 7. And you put that here and here. And you want to make sure that these middle x terms cancel one another out. So you make one of them positive and one of them negative. So we just factored this quadratic as the product of two binomials. And this becomes really important when you're solving quadratic equations. You want to use something called the zero product property, where you factor the quadratic and set it equal to 0. And that is what we have here, a nice factored form. So when you're doing a difference of two squares, you want to just take the square root of the first term, put that answer here and here, take the square root of the second term, put that answer here and here, and then separate them with one with a plus and the other with a minus. All right, so let's do another example. This is a difference of two perfect squares. What is the square root of x squared? It is x. What is the square root of 16? It is 4. These do not have a middle x term here. It's because it was canceled out, and it was canceled out because one was positive and one was negative. To check your work, if you like, you can go ahead and FOIL that. Use the distributive property to multiply these two binomials, and you get x squared minus 4x plus 4x minus 16. Notice that these middle 4x and negative 4x do cancel one another out, and you're left with x squared minus 16, which is what we started with, so it is correct. Alrighty, so you don't always have to check your work. That's just something I did there just to prove to you that it was the correct answer. Here's an example. Factor the expression 16x squared minus 121. This is a difference of two squares, difference of two perfect squares. And when I say that, I mean this can have the square root taken of it and you don't get a decimal. The square root of 16 gives you a whole number. This can have the square root taken and you don't get a decimal. It's a perfect square. 121, the square root of that is 11. So we're just going to use those answers on my calculator to write this final answer. It's a difference of two squares, so it's going to be equal to a binomial times a binomial. And the square root of 16x squared is 4x, because 4x when multiplied by itself is equal to 16x squared. The square root of 121 is 11. And since there is no middle x term, we must understand that one of these had to be positive and one negative, which is why there is no middle x term, because it got canceled out. And that's our answer. You could go ahead, FOIL that, check your work if you'd like. Here's another one down here. You could try this now. Pause the video, give it a try. Difference of two squares situation, because you have a perfect square in the first term, a perfect square in the second term, and they're separated by a minus sign. So we're going to factor this by writing out our little framework here of two binomials being multiplied by each other. The square root of 64x squared is 8x. The square root of 81 is 9. And we separate one with a plus and one with a minus. Done. Another few examples. This is not a perfect square. You can't take the square root of 125 and get a whole number as the answer. You get a decimal. The same thing for that 180. Now you do have a question like this in your Math Excel, and what I'd like you to do here is before you start factoring as the difference of two squares, see if there's a common factor that both terms share in common. Is there a number that evenly divides both 125 and 180? Let's find out. Looks like they're both evenly divisible by 5. We're going to factor that out before we even begin. How many times does 5 go into 125? Let's see. 125 divided by 5 is equal to 25. So this is 25x squared. Over here, how many times does 5 go into 180? It goes into it 36 times. There's a minus in the middle. All right, so all I did so far was I factored out the greatest common factor of 5. Now, if you just look at the thing in here, this binomial is a difference of two squares because each is a perfect square, each term, and we're going to go ahead and factor that. So I'm going to still have my 5x there, or my 5 there, and I'm just going to factor the thing that's highlighted in orange. 25x squared, the square root of that is 5x. So 5x times 5x would give us that 25x squared. 36 has a square root equal to 6. 6 times 6 is 36. And I want one to be positive and one to be negative. That'll give me that negative 36. And this is the final factored form. It's the final answer. And if there's any problem that might give you trouble in the Math Excel, it's this type. It's probably a little tricky, but you'll be fine now. You can give yourself a chance to try this on your own. If you want, you can pause the video, give this one a try. Is 700 a perfect square? Nope. Is 28 a perfect square? No. But if you factor out the greatest common factor, you will find some perfect squares. So let's do that. Math over 9, greatest common divisor between 700 and 28 is 28. So 28 is our greatest common divisor. They're both evenly divisible by 28. That's what we're factoring out. How many times does 28 go into 700 evenly? 25 times. So this is 25x squared. All right. 28 goes into negative 28, negative 1 times. And now we're just going to focus on this 25x squared minus 1. We have to factor that. Notice that 25x squared is a perfect square. The square root of 25x squared is 5x. And 1 is a perfect square. The square root of 1 is 1. Because 1 times 1 is equal to 1. Since it's negative 1, 1 has to be positive, 1 has to be negative, and that's it. That's our final answer. So if you would like to do some extra practice, this is completely optional, but if you want to sharpen your skills, there's a few pages in a few problems in the textbook on pages 526 to 527. This is completely optional. You can do some more work there. I'm going to upload these textbook pages along with this Google Classroom post. Thank you for watching. Please do the Math Excel assignment. It's due on Friday. Please feel free to reach out to me, ask me questions via email or Google Classroom, and please attend our video meeting on Monday at 2 p.m. I look forward to seeing you there. Thank you.